A logarithm is the inverse of a given exponential function. So I'm going to rewrite this one. So stop talking and listen. So if I've got something like 4 to the third power is equal to 64, the way to write it logarithmically, and that is actually a real word as well, is we take the logarithm, but instead of writing out the word logarithm, we use the abbreviation log base 4 of 64 is equal to 3. So it's really just another way to write an exponential equation. So here's what I want you to type. Big, all caps. Take your big text box, biggest one you can that doesn't totally annoy you. And if it totally annoys you, that's probably a good thing. I'm making mine 48.
A little bit.
Yeah. Logarithm. Let's make it caps too. Logarithm, I speak well, equals the exponent.
Slow motion.
Quicksilver.
Quicksilver is so dope.
You're like going slowly.
The kitchen.
Do you know he's really the son of Magneto?
Yeah.
But that's a whole other story. Okay.
Nice. I want this.
All right.
Yeah, because that's the thing.
They kept that part right. All right.
The other end.
So if we're going to write an equation in exponential form, first let's make sure this makes sense. So we change it in exponential form, and we'll see that the actual equation is correct. So my base is 2. The exponent is 3, because the logarithm equals the exponent. And what's 2 to the third power? 8. It's a bit bigger. That's it. So we change the logarithmic to an exponential. So this one, 4 to the power of negative 4. Well, 4 to the fourth power. 4 times 4 is 16. 16 times 16 is 256. But if I take the negative, it's the reciprocal, so it's 1 over 256. So logarithmic equation, exponential equation. They're both representing the same numbers, just in a slightly different way. Why would we ever use these? I'll get to that a little bit later. All right. So now we take the logarithmic one and change it to exponential. Remember, the logarithm equals the exponent. So my base is the little thing right next to the g. My exponent is 6. And that equals, because 3 to the 6th power equals 729. Okay. And I don't know why this is twice. So see if you can do the next one on your own. Take a moment. It'll take you more than 30 seconds. And when you're done, check up here to see got it right. These ones, you'll know you got it right because if the equation's wrong, so if you have like 16 to the second power equals 4, we don't know, we know that's not true. 4 squared is 16. Questions so far? Not too bad, right? Okay. It's a little harder now. So now we write log over. Ready? With the keyboard. Equation. Editor. Type in LOG. Get that caps off. LOG. Okay? And you'll notice something. It's a subtle but important difference. Whenever I type letters in the equation editor, they do it in italics, which means it's a variable. So the L looks like a variable. H, need you watch this. This is a visual thing. O is a variable. But once I put that G in, the equation editor knows. This is no longer variables, it's a logarithm. Okay, you can see it actually changes out of the italicized font. Now, we want log base 15. So right next to the 0 is a hyphen and an underscore, but we need the shift for the underscore. So shift underscore drops it down. 15. Go to the right. Remember, the logarithm is equal to the exponent. So I put that in first. I do things a little bit different. You know that. So 15 to the third power is equal to 3375. So the way we would say this, 2 ways you could say it. I've heard it both ways. The way I was told was log 3,375 base 15 is equal to 3. Some people say log base 15 of 3,375 3,375 equals 3. I don't care which way you do it. As long as you understand where the base and the exponent is. The exponent is on the other side of the equal sign. Logarithm equals the exponent. So on this one, dagnabbit. Well, before we do this, what does 1/2 power mean? What's 1/2 power mean? How quickly we forget.
Negative.
No negative nothing. Means the square root. Okay, so this is really saying the square root of 4 is 2. So now let's write it in logarithmic form. log underscore the base is 4. My exponent is 1/2, and then I backtrack. Okay. So 4 to the 1/2 power equals 2, or log 2 base 4 equals 1/2. Questions so far? Not too bad. Okay. You do those ones on your own. Take a moment, see what you can do on your own. Check with what I got up here, and I will take questions. Let's go back to blue. I think blue looks better here. LOG, base is 4, my exponent is 3, and I'm taking the log of 64. Over here, come on now. LOG, base of 125, my exponent is 1/3, so I'm taking that one. Questions? Different way. Okay, who's driving? It's like driving in reverse. Okay, not what you want to do all the time. Okay, but it's possible. Okay? And you don't have to do a lot of parallel parking around here, but when you parallel park someplace, you better learn how to drive in reverse. Okay, because when you parallel park, you don't pull into the spot, you back into the spot. Okay. All right, fill in the table. Some of you are changing into logarithmic, and some of you are changing into exponential. So logarithm to exponent, exponent to logarithm. So that's one thing you're going to have to learn. And that's the major topic of today. The other is this thing called the common logarithm. All right. So what is our number system based off of what major number? Nobody's been able to answer this in any of my classes yet today.
E.
Please make me happy. I thought I heard it. It's not E. It's not M. It's a number you're all familiar with.
0.
What did you say?
10.
Huh?
10.
One more time?
10.
10.
Yeah.
So a common logarithm. Okay, so make a text box.
No, I said math. I said one day you have that.
First person all day. Thank you, Noah. Okay. Common logarithm. It is so common, what don't we have to write? What's missing on all of these? The base.
Yeah.
Okay, so common logarithm is equal to base 10. So it is so common, when you do not see a number next to the G, it is understood that it's 10. Okay. Now, so far, all the ones we've done have worked out. So the numbers are pretty easy to work with. That is no longer the case. From this point forward, we're going to need Desmos. We're using a calculator. Okay, but before we use Desmos, slow your roll. Let's just talk what this would look like. Okay, so log 10 would equal what?
A 1.
Wow, how'd you get that so fast?
10. The space of 10. 10 well, divided by 10 is just 1.
Well, it's not divided. It's 10 to what power is 10?
Oh.
So remember, the logarithm is equal to the exponent. So 10 to the first power. So log 10 is equal to 1. So log 7, should that be bigger or smaller than 1?
Smaller.
Smaller, but pretty close to 1. So let's think about that when we take the logarithm in Desmos. Hey, look, I'm doing logarithms in college algebra too, but theirs are a little bit more complicated than yours. Hey, look at that. 1 times x times, ooh. Yeah.
Oh,
yeah. All right. So log 7. Okay. Can we go from Desmos back to Kimmy? Copy and paste? Yeah. So let's see. It says round to the 4th decimal. So how many decimals should we write? 5 and then round. So using Desmos, I'm going to grab from the 9 back. Copy. I'm going to go to my equation editor. I'm going to make my double squiggly because that's approximately equal to. And I'm going to paste, and then I'm going to look at my 9. Since 9 is bigger than 5, I round the 0 up to a 1. And then if we use that approximation and double check, so 10 to the power of shift 6.8451, that's pretty close to 7. Okay. Not going to be exact because I rounded. But I'm within 3 100,000ths. That's pretty good. Okay. All right.
Yeah.
So take a moment. Find the log of 0.5. Go ahead and do that. So log 0.5. Ooh, it's negative. Can we have negatives? Sure. Because remember, logarithm is the exponent. So could we take the logarithm of a negative, though? Let's try one. Let's try log negative 39. Nope. Okay. Because, what's my base? 10. 10 to what power is negative 39? You can't do that. It's going to have to be a positive number. I can never get a negative number if I have a positive base. And guess what? We're only sticking with positive bases. So that's going to happen every time. So you think that might show up on the test?
Yeah.
Probably. So keep that in mind. Well, your hope is going to be dashed. All right. So, I'm sorry. Forgot to grab it. So log. So grabbing the 5th one. Doing the copy and paste action. Coming back here. Doing a little squiggly and paste. 3.0102. Well, 2 means I just keep the 0. Do I need the 0?
No.
Nah. Okay. So, now let's do log 7 divided by log 0.5. There's a method to my madness. We're actually going to be doing this again a little later. Okay? So, should I just take these two numbers and divide them?
Yeah.
Bree's shaking her head no. Not sure why, Bree, but you know we're not supposed to do that, right? Okay. Round off error. Because we rounded this one, right? And we rounded this one. And then if we divide and round again, we've rounded 3 times. Every time you round, it's further and further away from what the actual answer is. So anybody use a photocopier? Okay, so the original always looks better than the copy, right? So I don't suggest wasting paper, but in the interest of science and experiment, if you ever want to do this, take your original, copy it. Take the copy it. Take the copy it. And about 5-6 times in, you're not even going to be able to read it. Okay? Because a copy of a copy, because what the photo imaging is doing is it's making an approximation of where everything's supposed to be on the paper, but it's never perfect. Okay? It's not going to work perfectly. So it's the same with mathematics. Every time we round, we get further and further away from the actual answer. So if we round 3 times, not so good. Now, it's not going to be that big a deal, so let's just take a look. So let's just do this. It was log 7 divided by, oopsies, log 7 divided by log 0.5.
Yep.
Okay, so, too many crickets. Divided by log 0.5. So this would be our answer. Again, we're going to take these first 5, copy, and do our double squiggly, and paste, and then the 5 means I round up to 4. Now I'm going to do it again, but use our rounded answers, and you can see the answer is going to be pretty dang close, but still not perfect. So we had 0.8451, right?
Yeah.
Divided by negative 0.301. So I'm accurate to within about 3 10,000ths. Okay? Because it's not until I hit that 4th decimal, which is the 10,000th place where I'm on. And who knows? Sometimes it makes a difference and sometimes it doesn't. Okay? When it comes to like these fine tables we have here, 3 10,000ths of an inch or a centimeter even, it's pretty good. They're not that close. Especially these two. Why is it important that these two are machined for me a little bit better than the others?
Because they're together.
They fit together.
What? For real?
Yeah.
Like, never thought about it? Nah, bro.
In a previous configuration of this room, I did have two of them together. All right. Okay, I have to talk about this, and I'm not happy about it because we're in the 21st century. This change of base formula was necessary when we didn't have calculators, okay? Because remember, we had the common logarithm. It's so common we have LOG, and we have a new one we're going to talk about in a couple days, and those are the only two that were around. Okay? Because if somebody had to calculate log base 4 and log base 3 and log base 2 and log base 7 and log base 8 and log base 34, it would take a long time. It took them a long time. They have books, literally books, that are, I don't know, 2-3 inches thick. You turn a page. If I want to know what the log of 10,346, I can find it in the book. Because somebody calculated it by hand many moons ago. Because they didn't have calculators. We have calculators today, right? So do we really need to change this into the common log? No. Are you being tested on it? Yes. Why? I don't know. So we're just going to live with it. All right. Well, except then you won't be able to do it on the test. So, log 3, or base 3 of 11. Let's just get a sense of what this should look like. 3 to the first power is 3. 3 to the second power is 9. So, log 11 base 3 should be a little bit bigger than 2. Because 3 squared is 9. Right? So, let's figure it out. Go ahead and dump it into Desmos. Log 11 divided by log 3. Log 11 divided by log 3. Here, look at it. And it's pretty close to 2 because 11 is close to 9. But we really don't have to do this. LOG underscore 3 of 11. Same answer. Believe it or not, when I was your age, I had to use a change base formula. Because even the calculators we had then only used log base 10 and log base E. It wasn't until the 1990s. The graphic calculators that you see around here that are older than you are, actually you can do a log of a different base. They had to upgrade the operating system. Yes, they have operating systems. In order to take the logarithm of a different number. Okay? So the first graphing calculator came out in 1988. You couldn't do it. All right. So with the log base formula, let's figure out what the answer is first and then prove it using big, heavy Desmos. So we're basically bringing a howitzer to a chicken fight. We don't need it, but it's just...
It's there.
It's there. Okay, so remember, this is asking the question. 3 to what power is 81? Don't say it out loud. Okay, so figure out what 3 to the power is. Hey, where can I find that? On my card. So take your card out and find 81. But find it next to the 3, not the 9, because our base is not 9, it's base 3.
I love Polonius. You like Polonius?
Oh, Hamlet?
Yeah.
He's a scumbag.
Hey, he has cool eyebrows though. Have you seen his eyebrows?
He has cool eyebrows.
He gets angry.
You know what? He may have been racist, but he's cool eyebrows.
Okay, anyway. What do you got, Denise? 3 to what power is 81? One more time? 4. So, like I said, we're going to use the howitzer here. So log 81 divided by, I keep doing that, divided by log 3. Hey, look at that, 4. 4 log base 3 of 81. 4. Okay, so see how the second way is slightly more efficient? The first way, I have to take logarithms of 2 numbers and divide. That's 3 steps. This one, I just take the logarithm of a number. That's it, done. Done. D-O-N-E spells moon.
What?
Wait, what?
Nobody's ever seen The Stand? Any Stephen King fans here?
Like
Oh.
I watched it.
Like it, except different. Like a dystopian future, like it kind of hits a little close to home, like this not a pandemic, like an epidemic where it wipes out like 90, 95% of the population.
Dang, that's
And
crazy.
divergent contact like a cell phone or something.
What?
Are we talking about cells?
No, the stand.
Oh, the stand. Never mind.
All right.
I just wish I would be just fucking.
So logarithm
Yeah, logarithms, yeah.
is equal to 4 because 3 to the 4th power is that. Or we could use our common base. Right now, what common base should you use? 10. Okay. If they don't tell you to pick a base, pick 10. Because that way you don't have to type anything else. Anything else, you're going to have to type, except when we talk about log base e, but that's another story. All right. Evaluate. So this is really saying, okay, 16 to what power? So I could actually make this into a little equation, okay, which is now saying 16 to what power is equal to 4. Okay? We've solved these before, so we need a common base. What's our common base going to be here? 4. Okay, so this is, we're going to do it the way we did it before. So 4 squared and an x. What's the power? Where's the exponent here? If there's no exponent, it's 1. So then 2x equals 1, so 1 equals x equals a half. So you see all those steps it took us before? Well, now we just take log 4 base 16. So log 4 base 16. You think Desmos will do that for me? Do you see why now sometimes it's easier to solve with logarithms? Instead of 4 steps, how many steps? 1. So log base 16 of 4. And if I want to make it into a fraction, I can. So 0.5 or a half. Okay? But every logarithm can be looked at as an exponent. All right. So again, let's get a sense of where we're going here. 3 to the 1st power is 3. 3 to the 2nd power is 9. What's 3 to the 3rd power? 27. So this has to be between 2 and 3. Is 20 closer to 9 or 27? 27. So I should have a number probably bigger than 2.5. Okay. So it says express it in terms of common logarithms, and then we'll evaluate it. Here we go. So log 20 divided by log 3. We'll copy and paste action. Oopsies, I forgot to start recording. Oh, it is being recorded. Okay. Is this between 2 closer to 3? A little bit bigger than 2.5? Okay. And I could, again, prove it. 3 to the power of 2. Ready? 0.7. Every number I put in gets me closer and closer to 20. It's 2. 6. Pretty close. 8. 3, 3. 0. 2.
Exactly.
7. 8. Okay. All right. Hey, guess what?